Knowing the slope of a function at a particular point can tell you a lot about the function. For example, if you were to find the derivative and you find that the derivative at some particular point is less than 0, you know that the graph of the function at that location must be going down, right? But if the derivative is greater than 0, then you know the function must be moving up. These are as you go from left to right, right? If you have a negative derivative, it means the slope of the tangent is negative, but a negative slope means you're going down from left to right. If you have a positive derivative, then you have a positive slope, so you know the function is going up from left to right. So for example, if we had this function, f of x equals x cubed minus 3x, the derivative of this function is 3x squared minus 3. Now, we can see that that is 3 times x squared minus 1 if we do a little factoring, which is 3 times x minus 1 times x plus 1. And now we see that we have the slope and we have a lot of information about the graph. If you look at the slope of this function, a couple important things. When x is either negative 1 or 1, the slope is 0. So at those locations, the slope is 0. If x is less than negative 1, we'll have 3 times less than negative 1 minus 1 is definitely negative, and less than negative 1 plus 1 is also negative. So we'll have a positive times a negative, that's positive. That means the graph of this function must be going up over in this region. If x is between negative 1 and 1, though, this number will still be negative, but now this is going to be more than negative 1, and so it's going to be positive. So we'll have a positive times a negative times a positive. That's going to be negative, which means the slope of the function is negative in that region, which means the graph is moving down. So here we know that the derivative is 0. Here it's positive. Here it's negative. Here it's 0 again. And then when x is more than 1 take away 1 will still be positive. And this will of course be positive because more than 1 plus 1 is definitely positive. So positive times positive times positive gives a positive. So we know the derivative is positive over here. This really tells us something about our graph, at least in terms of stick figures. It's moving up, it's level for a little bit, and then it's moving down till here, and then it's moving up. Okay, so that gives us something about the general shape of the function. Of course, if you think about the graph of x cubed minus 3x, you probably recognize it's got a little bit more curvature to it, like this, right? How can we find out about the curvature? Well, if you look at a place where the graph is curved downward like this, you can see that the slope, not only is the slope is positive here because the graph is going up, but the slope is decreasing. So if we looked at the way the slope is changing, which would be the second derivative, we would see that the second derivative is negative because the slopes are becoming less and less positive. Over here, on a piece of a graph that looks like this, it's still sort of curved downward. We call this kind of shape concave down, where it looks like a bowl that's upside down. The slope continues to decrease. So we go from slopes that are negative to slopes that are even more negative. So again, we have the second derivative less than 0. Where that changes is where the graph switches from being concave down to being concave up. At this point, you can see the slopes stop becoming more negative and start moving towards the positive. At least they start becoming less negative. So here, the slopes must be increasing. Now the second derivative would tell you how the slopes are changing, so the slopes are increasing if the second derivative is positive. That's going to be anywhere where the graph is concave up. So that will tell us something about the function. For example, if you look at this particular function, the second derivative, which just means to take the derivative a second time, is 6x. So the second derivative changes sign when x changes sign. If x is less than 0, we can see that the second derivative is negative, so the graph is concave down. If x is greater than 0, 6 times a positive number will be positive, the graph is concave up. The dividing line here is right when x equals 0. So over on this side, the second derivative is negative, which means the graph is kind of concave down. Right here, the second derivative is 0. By the way, that's called an inflection point. When you have a tangent line and the sign of the second derivative changes, you get an inflection. So it's sort of like being on a roller coaster. Here you're speeding up, speeding up, speeding up, speeding up. This is like the first chance that you could think the bottom is coming because the slopes are becoming less steep. Okay, so and then beyond this point, the second derivative is positive. Okay, that sort of adds flesh to the graph. So if you take the first derivative and it's greater than 0, then you know that it is increasing at that point. Okay. On the other hand, if the second derivative is less than 0, then it's going to be decreasing. Now, if the second derivative is positive, that means that the slopes are going to be increasing. So in this case, we would be moving up and getting more and more slope. So we'd see something like this, right? It'd be concave up. But if f prime was negative and the slopes were increasing, then we'd be moving down, but the slopes would be becoming less and less negative. You can see in both cases, if the second derivative is positive, you look like you're part of a bowl that's right side up. So you have a graph that's concave up. So it can be concave up whether it's increasing or decreasing. It's a matter of the way in which it's bent. If the slopes are becoming bigger, right, here we have a negative slope becoming less negative, so the slope got bigger. If the slopes are increasing, the second derivative is positive, so that the slopes are growing, then you know you're going to be concave up. On the other hand, if the second derivative is negative, then you're going to be concave down. Like in this case, if the first derivative is positive and the second derivative is negative, you're moving up, but you're moving up more and more slowly. So if you have extreme slopes to begin with, you'll have less slope later on. So the graph is going to be bent down like this. Here, you know you're decreasing, so the slopes are negative, and the slopes are decreasing, so they're getting more and more negative. So you start off with a slope that's initially slightly negative. Later, it will become more negative. Okay, so you can see whether you're increasing or decreasing. If the second derivative is negative, you know it's concave down. So the first derivative, the sign of the first derivative tells you whether the graph is increasing or decreasing. The sign of the second derivative gives a little bit of a bend to the graph. If the second derivative is positive, you have something that looks like it's part of a bowl up. It's concave up. If the second derivative is negative, it looks like it's part of a bowl down. It's concave down. We could use the derivative to analyze a function that we may have never met before. So first we look at this function and we see that it's x times e to the 2x. Now we know e to the 2x is always positive, so the sign of this function is going to be determined just by this x. When x is less than 0, the output's got to be negative, because the negative times a positive would be negative. But when x is more than 0, we'll have a positive times a positive. That will be positive. So just looking at the function without any calculus, if we draw a graph here, we know that before 0, the graph is here, right? After 0, the graph is there. Right at 0, the graph is on the origin. So that's a little bit to know about the function. Over here it's below the x-axis. Over here it's above the x-axis. That's a starting point. Now let's think about adding a little more detail here. So if we look at the first derivative, that will tell us about whether the function is moving up or moving down. If we take the derivative, that requires the product rule. Since we have x times e to the 2x, that's a product of two things I know how to take the derivative of. The derivative of the first, which is x, is 1 times the second, plus the first, which is x, times the derivative of e to the 2x, which is e to the 2x, times the derivative of 2x, which is 2. Now looking at this, if I factor out the common e to the 2x, I have 1 plus 2x times e to the 2x. Again, this part's positive, so if I want to know about the sign of the derivative to figure out whether this is increasing or decreasing, I just look at this piece. If this piece is negative, then it's going to be decreasing. If this piece is positive, then a positive times a positive is positive, so it will be increasing. Now, where this changes is when x equals negative 1/2. So if I draw negative 1/2 here, when x is less than negative 1/2, then we have a very negative number. Plus 1 is still negative, so the graph is moving down in this region. Not only is it below the x-axis, which we knew from looking at the function, we know that it's moving down at that point. Then after negative 1/2, so here the derivative is less than 0. After negative 1/2, the derivative becomes positive, because if the number here is more than negative 1/2, then this is no longer enough to overwhelm that 1. So it's a positive times a positive is positive. So after that point, the function starts moving up. So it starts moving up, and we know that eventually it crosses through here. So it moves through here with a positive slope. Okay, so we have a function that is going down to this point and then going up. We have kind of a very stick figure like graph of that function. Okay, just putting together what we got from the function, looking at the sign of the function and then the sign of the first derivative. If we want to put a little bit of curvature on this, or a little concavity is the better word, on this function, then what we can do is look at the second derivative. To get the second derivative, we need to take the derivative of the first derivative. And this is a product of two functions we know to differentiate. So we take the derivative of the first, which is 2, times the second, plus the first, which is 1 plus 2x, times the derivative of the second, and we know that derivative of e to the 2x is e to the 2x times 2. Both of these terms have a 2e to the 2x. If I factor it out, it leaves behind a 1 and a 1 plus 2x. So we get 2e to the 2x times 2 plus 2x. Let me go ahead and factor out this other 2. If I do that, I get a 4e to the 2x times 1 plus x. This guy is positive, e to the 2x is positive, so the sign of the second derivative just hinges on this term, 1 plus x. You can see that the change occurs when x is negative 1. When x is negative 1, the second derivative is actually equal to 0 when x is negative 1. If x is less than negative 1, then this negative number will overwhelm the 1 and we'll have a negative. So the second derivative will be less than 0 at this point. That means that the graph is going to be concave down. Now, after this point, negative 1, though, the second derivative becomes positive, because if the number is to the right of negative 1, when you add a 1 to that, that will pull it to the positive side. So after that point, the graph is going to be concave up. So initially, the slope is still downward, but it's concave up. This puts a little curvature on a function. We knew from looking at the function, it's always below the x-axis, that is decreasing and concave down until we get to negative 1. And at negative 1, a change happens. It stays decreasing for a while, but it begins to be concave up. So we see the graph curving up like this. So together, looking at the function, its first derivative and its second derivative, gave us a good idea of what the sketch looks like. It's concave down and decreasing below the x-axis until you get to negative 1. It continues to decrease, but the concavity changes. It starts to have less and less negative slopes until right here the slope is actually 0. The graph is just level for less than an instant. And then the graph goes up through 0, 0 and continues to be concave up. That's pretty powerful analysis. We found out a lot about that function without actually having to draw the graph. But if we did draw the graph, we would see this. Let's look at our function. The original function was y is x times e to the 2x. If I draw that graph, sure enough, you can see that picture agrees. In fact, if we zoom in on the area where we were sketching it, zoom in here, see that it's always below the x-axis, but when you get to negative 1, a change occurs. It stops being concave down and starts being concave up. Eventually, the slope becomes 0, where the graph has this level spot for just a second, and then the slope starts to increase, always moving up, and at 0 it starts increasing, eventually crosses through the x-axis, and continues positive after that point.